join today's webinar. In the first part of the webinar, I would like to talk about screening and quantitation of mycotoxins in food by triple quadruple and also QTRAP LC MS instrument. We all know a large number of toxic substances, for example, like pesticides, antibiotics, mycotoxins, and all other toxins are found in food and beverages. And in most of cases, those compounds are present at very low level of concentration, at the same time in very complex matrices. That means one side, the need for food testing, and also another side, the need for the analytical method is increasing rapidly. So nowadays, we can say analytical method such as GC-MS or LC-MS, LC-MS involved in many aspects in industry food production and food safety testing and global trading, and so as well as we can say in our daily life. So most important thing for us is to provide a robust method for food testing and food quality control, import, export testing, and also sometimes for disaster monitoring. When we talk about application type in food and beverage area, normally we can say divide that to roughly to two parts. The first one is nutrient composition analysis. In this part, normally we're analyzing, for example, amino acids, vitamins, fatty acid, or proteins in the food composition. And another part is we call now nutrient analysis. Contaminants testing is, of course, very important part here. Also, mycotoxins is an important aspect in this contaminants testing. What is mycotoxin? Mycotoxin, we normally say mycotoxins are secondary metabolites produced by different type of fungi genus. For example, we can say aflatoxins, ultratoxins, and some others. Also, we know, for example, aflatoxin different compounds, B1, B2, G1, G2, for example, so are very toxic, even at a very low level. On another side, we also know that more than 25%, for example, our agricultural goods are contaminated with mycotoxins. Based on this fact, now we know that over 100 countries have regulations for control mycotoxins both in food and feed. And the levels of mycotoxins present in food are normally highly controlled by different kind of guidelines. Here, just one example of this kind of regulation. SDA gives us minimum reporting limits for mycotoxins in different kind of food. For example, you see here for aflatoxin M1, the limit is 0.1 microgram per kilogram in milk, and for petroleum, for example, is 50 microgram per kilogram in apple juice, or all other kinds of processed food which contains apple. Now, think about this regulation and move that to analytical method. What is the need for analytical methods? Of course, first of all, any method needs to be compliant with regulation. Even this may be geographically change a little bit. It's from country to country, a little bit different, but these are typically very close to what we see in the EU, which I listed below these two regulations. Also, and another point, in order to for example, reduce the analysis time and reduce the cost. We also need to try to combine different recent reference methods into a single method, so we can monitoring different classes of mycotoxins and different kind of mycotoxins in one single injection. Of course, it's also very important we need to test and validate this method in different matrices. Okay, so with this, I will hand back to Lauren to raise one audience poll question.
Thanks, Jianru. So for our first audience poll, we just want to ask you, what are the top 2 biggest challenges that you face in doing mycotoxin analysis in foods? Is it sample preparation, overcoming matrix interferences, analyzing diverse mycotoxin compounds in one analysis, sensitivity of the instrumentation, meeting regulatory limits, requiring validated methods, or I do not currently test for mycotoxins? So again, what are the top 2 biggest challenges that you face in doing mycotoxin analysis in foods? And when we look at our results, we can see that it looks like the biggest challenge faced is analyzing diverse mycotoxin compounds in one analysis. So I'll hand this back to Jianru, and I'm sure she'll talk a little bit about analyzing different mycotoxins in a single analysis as she continues with her presentation. Jianru?
Yeah. Still uploading. Okay, so now I would like to present our results and the method we used here. And this method we use for both screening and also quantitation. First of all, sample preparation. We use very generic and simple sample preparation method. We take 2 grams of sample, mix that with 8 milliliter acetonitrile water 80-20 for about 20 minutes. Then we centrifuge it for 10 minutes and use filtering afterwards. And after we filter the sample, just dilute that 1:4, and then the solvent now is ready for injection. HPLC, what we use here, the condition here, the method, you can see are listed below. So the run is 8 minutes run. We use buffer A, water, plus 5 millimole amino acetate, and 0.5% acetic acid. Buffer B is methanol, plus ammonium acetate and acetic acid. Column what we use there here is phenomics kinetic 2.6 micron, XP C18 column, and we use a flow rate 500 microliter per minute, and the sample injection volume is 30 microliter. Okay, so SCIEX 5500 instrument, QTRAP instrument was used here, and on the left side you can see the source conditions, what we used here for both positive and negative ionization models, gas condition and temperature. One of the benefit of this instrument is fast scan speed. That means you can do so fast, so high speed scan that makes you possible to switch positive and negative ionization models back and forth very fast. That means you can just use one injection get both positive, negative spectrum. And also the sensitivity of this instrument allowed us to reach the different regulations here. Also, scheduled MRM was used here for monitoring different kind of mycotoxins. Why scheduled MRM? Just like we talked, from our questions we have already asked. So sometimes it's important if you want to run multiple mycotoxins. That means you have a lot of transitions here. It's important to make sure that your method can do targeted analysis, only monitoring them at the expected retention time. That means you can see from this picture, some certain MRM transition will be only monitoring on some special window. In this case, you can run a lot of analysis and you can get enough data points for each MRM transition. I will show you with some spectrum, you can see the benefit of scheduled MRM. This is the method what we used here. So you can see for different mycotoxins, you can see the retention time and polarity what we used, and also according to the regulation for each mycotoxin we have at least 2 transitions, and you also can see for some of them we use different kind of adducts. And very important thing here is we run both positive, negative ionization models with scheduled MRM in one single injection. What you can see here on the top is negative polarity, and down on the bottom picture is positive polarity. All of these you get by one single injection with 8 minutes run. So we talk about scheduled MRM. What the benefit? If you compare these results, on the top is with scheduled MRM and down is with normal MRM without schedule. So you can see both in terms of data points and also in terms of signal to noise, you will get big improvement by using scheduled MRM. That means you can increase the sensitivity just by using this kind of software. So this on left side is one example in negative polarity, and the right side is one example in positive polarity. So you can see for both polarity you will get better sensitivity with scheduled MRM. So in terms of quantitation, I just show you one slide here. You can see with triplicated injection for aflatoxin B1 at 0.4 nanogram per mil, we can get a percent of CV about 4. And the bottom picture, you can see the calibration linearity for concentration from 0.4 nanogram per milliliter up to 40. Of course, for this method, we also tested that in different kind of matrices. I cannot show you all of them. Here's just one example. The standard was spiked into extract the baby cereal samples. So in the middle, you see the blank of this baby cereal extraction is now peak. For example, down when we spiked aflatoxin B1 in 0.4 nanogram per milliliter, and the right side is spiked 10-fold lower concentration, 0.04 nanogram per milliliter, you still have a signal to noise about 80. That means that is still above AOQ for the instrument. Okay, so with this slide, I just want to show you the further possibility with this instrument, that is by when you're using linear N-trap. without going very deep to the principle of linear NTRAP or how it works, just from this spectrum is that when you just slightly modified your method I presented before, just added on one extra experiment by using linear NTRAP, you can get full-scan, high-quality full-scan MS-MS spectrum. Software will automatically compare this acquired MS-MS spectrum with library MS-MS spectrum. In this case, that means with single injection you get screening MRM quantitation. Also, you can use library to identify the compound in your sample. This is just one example. Okay, so the next few slides, I want to show you some results. We use microLC for mycotoxin analysis. Of course, the question here is, will microLC bring us any benefit for this mycotoxin analysis? So, what is needed for microLC? Of course, first of all, we need a high-pressure binary pump, which allowed us to use a flow rate, for example, between 5 and 50 microliter per minute. We need to have a very low delayed volume. Of course, we need to have a high throughput autosampler. And of course, we need to have reproducible low injection volume, because in this case, we normally inject quite low injection volume. What we used here is Expert microLC 200 UPLC system. This one gives us possibility to run flow rate 5 to 50 microliter per minute or 20 to 200 microliter per minute. Depends on the column you selected, different ID column. And also for this microLC system, the pump does not use any split. That means in this case you can save a lot of, for example, buffer. And the maximum back pressure here is 10,000 psi, and the delay volume here is just 1 to 3 microliter. You can inject the sample from 15 nanoliter up to 10 microliter without needing to change loop. Okay, so if we use microLC, does the MS source need to be changed? And how is the change? If we need to change that, is that easy or very difficult? You need to break up your instrument. So, of course, here you can see for microLC, we need to change the spray probe. That means because now the flow rate is very low, we need to use kind of a spray probe with smaller inner diameter. For example, you can see here for 25 micron ID spray probe, we can use that for 5 to 20 microliter per minute, and 50 micrometer ID for 20 to 100 microliter per minute. But this change can be done very easily. You just need, you can see here, just take off the normal spray probe and put the new one in. That's it. Then it's finished, ready for measurement. So the HPLC condition, what we used here, listed here is same, 8 minutes run. We use C18 halo column and inject a 10 microliter sample. And in this case, we use the 4500 QTRAP system from SCIEX. And of course, we need to change or optimize a little bit source condition because we are using now low flow rate. Results. What is the benefit by using microLC? The first things you can see here, compare the normal HPLC high flow with microLC. So what you can see here is improvement definitely in signal to noise. That means it's definitely we can improve sensitivity in this case. Of course, another question is how good is reproducibility with microLC? Is that good enough? Is that the same as normal high flow LC? Here's just an example. We spiked the 2 microgram per kilogram aflatoxin B1 into 0 matrices. You can see on the top is replicated 6 injection with the intensity, and the lower the table we show you the injection for some different kind of mycotoxins at LQ level. In this case, is 0.05 microgram per kilogram with CV, percent of CV, and the standard deviation. So all of this, what we see here, meet European regulation here. Okay, so of course the next question will be, do we still need to improve the detection limits? Of course, what we show now is normally the regulation limit for adult food. If we want to go to the range of baby food, we do need to improve the detection limit. One possibility, of course, is to use next generation of instrument. So, SCIEX instrument 6500 system, that is our most sensitive triple quadruple instrument. Compared to 5500, this will be up to 10 times increase in sensitivity. Also, because of a new kind of detector, we can improve also the dynamic range for the quantitation. So that means we have possibility to even monitoring more different classes of mycotoxins. I just want to show you one slide here, even this is not measuring mycotoxins. And this is a comparison between 6500 and 5500. It's a mixture of different kind of pesticide standards. So you can see we have a big improvement in terms of intensity. Also in terms of calculated signal to noise, we do have a huge improvement by just using 6500 compared with 5500. And we just started to measure some mycotoxin samples on 6500. I hope we can present you some new results next time when we finish our measurement. Of course, another side is also we try to, in cooperation with our partner, to try to optimize, try to do automatic sample preparation. I just show you one slide here, just we work together with our partner. With this system, you can do really automatic sample extraction and also cleanup, and afterwards direct injection to the mass spec instrument. Okay, so with this, I want to go to the conclusion. The first thing we really see here that scheduled MRM can enhance sensitivity and fast positive negative switching, enable to screening multiple classes of mycotoxins in one single run. And for QTRAP 4500 LC-MS system can already used to meet the needs of European regulation. And microLC is one possibility that we can use that to increase the sensitivity of our testing system. With microLC, of course, what the put that here is that you can save the cost regarding buffer what you used. And of course, another further work, another step is that with use 6500, we can lower limit of detection, try to fulfill the further European regulation, for example, for baby food testing. Okay, so with this, I've finished my talk here. Lauren? I think maybe.
Jianru. If anyone has any questions for Jianru, you can submit those at the top left of your screen. We do have one question in Jianru for you, and the question is, do you ever have to do an SP or a sample cleanup when you're doing your multi-mycotoxin analysis?
Yes, for some kind of matrix extraction, we need to do that. The results, what we show you here, the spiked standard in series sample, that's without SPE cleanup.
Okay, thanks, Jianru.